Hi everybody. This is the third part of the calorimetry experiment, and we are measuring here the heat released by a neutralization reaction. So we are using milk magnesia. This is the milk magnesia that I got. I'm going to send you pictures of the labels and the ingredients. But it says that the active ingredient is magnesium hydroxide, 1200 milligrams in each 15 milliliters. So the magnesium hydroxide is already in here, and I measured the mass of the calorimeter plus the mass of the solution. I measured about 30 milliliters, but as you can see, we have some residues. So it's important for us to measure the mass of the solution that we put in there. And we are going to combine this with vinegar. So this is the vinegar that I got. And as you can see, it's 5% acidity. So we're going to assume it's 5% acetic acid. And I measured about 99 milliliters of that vinegar because I want the neutralization to go completely. So you guys will calculate the moles of magnesium hydroxide and moles of vinegar, and you will see that the idea is that it's a 1 to 2 moles of magnesium hydroxide to acetic acid. Now, for the calorimetry experiment, we are measuring temperature, so I'm going to turn this on. We have the temperature probe here that is sending the data to the data logger or tablet. So the temperature of the solution inside this is about 21 Celsius. We have a magnetic stirrer in there, so I'm going to start stirring. I'm just going to collect a couple of more data points at the beginning. And to find the heat of the reaction, I have to carry the reaction inside the calorimeter. So to do that, I'm just going to add the vinegar here. I'm going to continue mixing with the stirrer, and I'm just going to hold this here so the lid is on top of the cup. We record the temperature, and we can see a small increase of temperature right now. We're just going to keep stirring for a little while, maybe 1 to 2 minutes. Temperature is going up. It's around 23 Celsius now. So after finding out the delta T, so the change in temperature of the initial solution and the final temperature of the solution or the mixture, we can calculate the delta T, and having the delta T, we can calculate how much heat was released by this reaction. We can decide if the reaction is endothermic or exothermic. We have to take into account when we calculate the heat released by the reaction, who are the surroundings, and how do we calculate that heat, because the heat released by the reaction is going somewhere. So part of it is going to the calorimeter, and the other part of it is going to, that's something that you guys have to think about, because you have to do the energy balance here to be able to find the heat released by this reaction. Seems like the temperature is going up, and there is a little shoulder there. But we are going to record this until the temperature becomes constant. So we'll see a flat line, and then the temperature will slowly start dropping. But we're going to record for a few more minutes, and I'll provide this data for you guys. So I'm going to cut the video here, because for the purpose of explaining how to find the heat, experimentally how to find the heat of a reaction, this is what we do. We mix the two solutions in the calorimeter, and we find the temperature profile for the reaction.